Welcome to Red Dragon Mission Training number 2, Constant Velocity. This training video will cover the following learning targets. It's your mission to master as many of these learning targets to the best of your ability. In order to understand speed and velocity and the difference between them, we need to look at distance and displacement. Distance is the measure of the path taken. It's a scalar quality. It has magnitude only. It's only a number. It does not have direction. So if we have a start and a stop point, distance is the path that you traveled. It's not straight line from point A to point B. It's however far you walked. This is how the mileage in your car is recorded. Displacement is the measure of the distance between the start and the stop point. It's the straight line measurement that shows you how far you are from where you started. It's a vector quality, which means it has magnitude and direction. So if I look at my start and stop point, there's distance, there's displacement. Not only can I find a numeric magnitude to represent that change in position, I can also describe the direction, in this case, mostly forward. Speed is related to distance. It's how fast an object is moving. It's distance divided by time. That's how you calculate speed. Since distance is a scalar, speed is also a scalar quantity. This means that neither distance nor speed have direction. To calculate speed, we're going to take the general formula of total distance over total time. This is to find the average speed. So if I knew how far I drove on a road trip and how long it took me, I could divide the two to get the average speed. Speed is related to distance, velocity is related to displacement. Velocity isn't just how fast an object is moving, it's also which direction it's headed. So when we calculate velocity, we have to take displacement over time, with a direction included. This could be north, east, forward, up, down. Because it's a vector, it has both. Displacement's a vector, velocity's a vector. So positive velocity is forward or up. The positive or negative quality of the magnitude tells us which direction it's moving. So a negative velocity is backwards or down. So in some cases, you may not always be told the direction forwards, backwards, up, down, but the sign of your velocity automatically tells you whether you're going forwards, backwards, up, or down. To calculate average velocity, take the total displacement divided by the total time. We already know that velocity is how much distance an object travels in a given amount of time. Constant velocity is velocity that it does not change. It does not speed up. It does not slow down. You start and finish moving at the same exact velocity. We can represent velocity on a position versus time graph. A position versus time graph is a graph where position is plotted on the y-axis. The unit is meters. Time is plotted on the x-axis. The unit is seconds. Velocity is the slope. So in this case, my dependent variable is position, my independent variable is time. That's a position versus time graph. As we interact with position versus time graphs, we start to see trends in the slope. The steeper the slope, the more distance covered in a set of time. In other words, the faster the object. The shallower the slope, the less distance covered in a set time. Or in other words, the slower the object. If you have a zero slope or a completely horizontal line, there's no distance traveled in that set amount of time. In other words, you have zero velocity, zero slope, zero velocity. The object is not moving in this case. When we look at objects moving in opposite directions, a positive slope is moving forward. So car A is moving forward because it's a positive slope, moving away from the starting point or y-intercept. The negative slope, car B, is moving backwards, moving towards the starting point. In this example, Jim Shu runs the following route in 2 hours. Find his distance, displacement, speed, and velocity. So he runs 8 miles to the east and then 6 miles north. Distance measures the path. So he traveled 8 miles and then 6 miles to get a total of 14 miles. He traveled this distance in 2 hours. To find his average speed, I would take 14 divided by 2 hours to get 7 miles per hour. Displacement is the straight line distance between where you start and where you end. In this case, if I'm looking at a triangle, it's my hypotenuse. A little basic trig would tell me that displacement is 10 miles. 10 miles northeast, because he went 8 miles east, 6 miles north. I need a direction and a magnitude. So to find the velocity, I take the total displacement, 10 miles, divided by the total time to get 5 miles per hour in the northeast direction. Direction is very important. In most cases in physics, it's as simple as forward, backwards, up, down, but in some cases we start using our cardinal directions, north, south, east, and west. Try finding the distance, displacement, speed, and velocity of this graph. To begin, I can look at the position change. So the first leg of this journey, we went from 2 to 4. That's a distance of 2 meters. Once we were at 4 meters, we walked backwards all the way back to 0 meters. That's another 4 meters. So I walked 2 forward, 4 backwards. That's a distance of 6. Total distance divided by total time, in this case 4 seconds, you divide it to get 1.5 meters per second. Notice that these just have quantities, just magnitudes, no directions. Displacement, however, does have direction. I look at my straight distant measure from my starting place to my ending place. My initial position is at 2 meters. My final position is at 0 meters. I went from 2 all the way down to 0. Now to get there, I did go 2 forward, 4 backwards, but we're only looking at the distance between start and end. In this case, it's 2, but it's 2 in the negative direction, the backwards direction. So my displacement is negative 2 meters, or 2 meters backwards. My velocity is my total displacement over my total time. It's the same amount of time. It still took 4 seconds, so I'm going to divide by 4 to get negative 0.5 meters per second backwards. Again, in this case, the negative 0.5 and the backwards is redundant, but you need to know what is the magnitude, so the numeric measure, and what is the direction, since this is a vector measurement. When we describe any motion, we need to think about a couple characteristics. First off is the direction. Are we going forwards? Are we going backwards? Are we stopped? Forward and backwards often are interchangeable with up and down. You need to have a positive and a negative direction. You can also look at the type of motion. Is it a constant velocity? Are we stopped? Are we accelerating? In this case, speeding up or slowing down. You can also talk in terms of relative motion. Are you moving slower than other objects? Faster than other objects? When we talk about motion, we need to keep all of these characteristics in mind. When we use our position versus time graph, we can describe the motion of objects with a great detail. Let's look at car A. Car A is moving backwards. We know that because it's a negative slope. It's falling on the right. The positive or negative quality of the slope tells you which direction it's moving in a position versus time graph. Constant velocity. I know it's constant velocity because a straight line on a position versus time graph or a direct relationship tells us I have constant velocity. That straight line tells me that the relationship at the beginning of the motion and the relationship at the end is the same. I can also assume that it's moving faster than car B and C because it's steeper. Even though it's a negative slope, the negative just tells me that it's going backwards. It's still steeper than car C. The steeper the line, the faster the object. On your own, describe car B and car C. Car B has a slope of 0. It has a horizontal line, so that means it's stopped. There's nothing else to describe other than the fact that it's stopped. Car C has a positive slope, so it's moving forward. It's a straight line, so it's a constant velocity. It's shallower line, so not as steep as car A's slope. Because it's shallower, it's slower than car A. It's also going in the opposite direction of car A. The kinematic equations are equations that allow us to predict and calculate motion. They're derived from the relationship between position in time, velocity in time, and the relationships between acceleration and time. When dealing with kinematic equations, your knowledge of variables and units will really help you. X is displacement. A is acceleration. T is time. V is final velocity. That's how fast the object is moving at the end of the scenario. V sub 0 is initial velocity. That's how fast the object is moving at the beginning of the scenario. All of these variables have units that correspond. X, or displacement, is measured in meters. A, acceleration, is measured in meters per second squared. T, time, is measured in seconds. Both final velocity and initial velocity are measured in meters per second. Final velocity describes how fast an object is going at the end of a motion. Initial velocity describes how fast it's moving at the beginning. They're the same unit, but describe different parts of the motion. In the left-hand column, you have 4 basic kinematic equations. You choose which of these equations to use based on which variables are not included. 3 is the magic number with kinematics. You have to have at least 3 given pieces of information. One of those variables you'll be solving for, which means that the 5th one is not included. You only need 3 givens and 1 unknown. That 5th one tells you which equation to use. If x is not included, so displacement, you're going to use v equals at plus v sub 0. If final velocity is not included, you're going to use x equals 1/2 at squared plus v sub 0 times t. If t is not included, you'll use v equals 2ax plus v sub 0 squared. If a is not included, you'll use x equals 1/2 quantity v sub 0 plus v times t. If you have a copy of the equation derivations, you have a lot more options for calculating the missing information. If you just have those 4 basic equations, you can solve for any unknowns. If you have the derivation chart, you can just plug and chug, use your order of operations to find the unknown variable. In order to find the right equation, step 1, find the variable that's not included in your scenario. Step 2, select the derived equation based on the variable you are solving for. So in this case, I have 50 meters per second for the final velocity. Initial velocity is 50 meters per second as well. That means it's a constant velocity. It started and stopped at the same velocity. I'm also given that t equals 10 seconds. That means that x is what I'm looking for and a is not included. The scenario or the word problem will give you those three givens, tell you to look for x or displacement, and then because acceleration is not discussed, it's not included. So I'm going to go to the A is not included. If I was just using my four basic equations, I would be using x equals 1/2 b sub 0 plus v times t to solve. If I have the derived equation sheet, I'm solving for x, so I'm going to find the equation that starts with x. In this case, it's the same one. If I had another example, look at the given information, what's not included in what you're solving for in order to find the right equation. Try it on your own and then come back to the video when you're ready. In this case, acceleration is not included. I'm solving for t because I put a question mark next to it. So there's the equation I would use. This is the most efficient equation to use in this scenario. In order to solve a kinematic equation problem, you're going to follow the same steps every single time. Step 1, list your given variables, including the units, to make sure they match up. For example, meters goes with displacement, seconds goes with time. It's a great way to make sure that you've put the right variable with the right variable. Step 2, figure out which variable the problem is asking you to solve and which variable is not included in order to select the correct kinematic equation. If the word problem or scenario asks for the time, put a question mark next to t. That's what you're solving for. Whichever other variable is not given to you, that's what's not included. It's a process of elimination. You're given three given pieces of information, you're given one to solve for, and then you're given one that's not included. Step 3. Substitute the given values into the equation. Plug and chug. So we're going to solve or evaluate for the missing variable. Now I need to make sure that the proper unit is on my answer and see if it's reasonable. Reasonable usually means check, is this number too big or too small based on your experience? Is the sign correct? If the object's moving forward, the velocity should be positive. If the object moved backwards, it may have a negative displacement. If you're doing a kinematic equation problem and you know you have constant velocity, there are a couple things that you can start off with. Initial velocity and final velocity are the same. If you know the final velocity is 5 meters per second, the initial velocity is 5 meters per second as well, and vice versa. Acceleration is 0. In this case, we're going to assume that the acceleration is usually not included. Here's an example problem. A man walks at a constant velocity of -4 meters per second for 3 seconds. How far did he travel? Which direction did he travel? On your own, try writing out the given information. List the unknown variable and the not included variable. Your final velocity is -4 meters per second. Because it's constant velocity, you also started at -4 meters per second. T is 3 seconds. They gave us that. How far did he travel? Which direction did he travel? It's asking how far, so that's x. It's my displacement. A is not included, so acceleration is not included. Based on this information, on your own, select the correct kinematic equation. A is not included. We're solving for x. There's the proper equation. Now that we have all of our given information, we have our equation, we can plug and chug. We would substitute everything in. -4 for initial, -4 for final, and 3 for time. On your own, calculate how far he traveled and in which direction. If I go through and follow my order of operations, -4 plus -4 gives me -8. Half of -8 is -4. -4 times +3 gives me -12. I need to make sure I have units, that my answer is reasonable, so that's -12 meters. Negative means he's walking backwards. In this case, since he walked -4 meters per second, that's backwards, it makes sense that he has a negative displacement. That's reasonable.